All right, so welcome everyone to today's COE meeting. I'm Rahul Mangharam. I serve as the director of the Autoware Center of Excellence. Autoware COE's mission is essentially to be the R&D source and contributor for Autoware. It's basically a network and a collaboration network of academic people from institutions who are all working on different aspects of autonomy, not just autonomous vehicles, but autonomy with AI, machine learning, controls, and building full stack systems. Almost all the COE members use Autoware, and our goal from the Center of Excellence from the Autoware Foundation is to help all partners, you know, ease the burden on using Autoware, and all partners who are doing research, we also help them basically make active and effective contributions to Autoware. And I'm joined in our team with Pojan Wang, who is the Autoware engineer. He's a robotics engineer, autonomy engineer, software engineer. Pojan can help all academic partners with onboarding, um, and with basically any kind of technical question. And we are backed up by Ryosuke Mitsudome-san, who is basically the chief architect of Autoware. And any kind of questions related to how do I make a contribution? What kind of features are there in Autoware? How do I use this kind of localization? Or I want to integrate a new sensor. I want to use a new platform. We can help you answer that. Also, I want to just introduce Mike Coraluzzi. He serves as the project manager. Since we launched the Autoware Center of Excellence projects, we have over a dozen projects that are getting activated now, and Mike and Pojan are helping streamline that process. So very briefly, I'm just going to share with you how we are going about doing these Autoware Center of Excellence projects. And to begin with, the purpose of all of these projects here is essentially to uh, to allow, first of all, to allow Autoware to help researchers with their projects. And because, as researchers, we want to focus on the algorithms, we want to focus on publication, want to focus on the intellectual aspects. And building a platform takes a lot of time and effort. The thing is that all of us are building these platforms, and there is a common aspect of getting the platform working, and that's where we help. And so we started this Center of Excellence projects essentially as a more formal way for the COE to help partners and for the partners to contribute back. And so we have outlined here, basically a standard operating procedure on how these projects work. So what is the purpose? What are the responsibilities? How does your project start? And then how we define everything. Each member over here will have an opportunity to submit a project proposal and a description. And then Pooja, Mike, and I will basically meet with y'all, make sure that the project is both useful and we can help you with that. And then there is essentially, if we, I'll just show you the actual files that we actually use, right? So we have overall like a project tracker sheet like that, right? So we are basically, each project basically has a tracker for, and this is what you would maintain. Maybe let me see if I'm sharing my screen appropriately. Oh, and yes. So each partner would have this kind of sheet. Also, what we do is we also have a status of who we have spoken to, and again, we are always updating the status over here, but it's just for us to keep track of all the projects, and who has onboarded, who is confirmed, and so on, right? The other aspect is that you will get all projects that have submitted a description. At least for the first 12 projects, we will have AWS COE credits. And the Amazon credits go up to 10,000 credits for a project. And this is really just, Amazon AWS is a premium partner of Autoware Foundation. and they have provided us with credits to share. And my goal is to share with everybody and use the credits for your project. Please exhaust the credits. Don't save them because they will expire then. And so you will receive this form once your project has been submitted and approved. And it's a very informal process, but it's still a systematic process. So for example, I'll show you Junfeng's, he has a project proposal that he has submitted, and this is the details of the project, and this is a form that has been filled out, and we don't have to go into the specific details, but we can share this as a template. It's a very well defined and outlined project. So thank you, Jinfeng, for all the details. And essentially, it's highlighting what is so just practically like 2.5 pages, and that's it, right? So we are not really obsessed about that. And then Junfeng has his own tracker, and then the tracker is basically the different milestones that he has that are to so that we can make sure that that the contributions are actually effective and useful with that, right? So I'll stop there sharing my screen, and if there are any questions, we can go through the different project ideas and also updates from different teams, and any other open questions. But first, I would like to have Shoaib Azam, who was recently introduced to us from Alto University, and he would like to present some of his work. And so please welcome Shoaib. Please go ahead, Shoaib. You can
Yeah,
share your screen.
thank you
Thank
so
you.
much. Thank you for inviting me. So I will just share my slides. Um, okay. So can you see my slides?
Yes, yes.
Okay. Yeah. So once again, thank you for inviting me, and thank you for the invitation to be part of this Center of Excellence Autoware project. So today I will just talk about my research, and the topic which I choose for this presentation is world models for end-to-end autonomous driving. So I will briefly go over my research background and what currently I'm doing, and uh, what is kind of contribution I can make to Autoware, and in back what I can receive back from Autoware. So let's dive in. So a little bit introduction about me. So I done my master's in robotics and intelligent machine engineering from National University of Science and Technology from Pakistan, and then I moved to South Korea, and where I have done my PhD in electrical engineering and computer science, and my major was machine learning and deep learning, and developing machine learning and deep learning solutions for um, autonomous driving based on Autoware. And then after completing my PhD, I remained there in that lab for about, I think, 1 year as a postdoctoral researcher, and work on kind of mobile robotics over there. And then I moved to Aalto University, and now I'm part of Aalto University, as well as I'm also part of Finnish Center for Artificial Intelligence. And here kind of in the group, I'm kind of only one who is working on autonomous drivings, and also developing safe planning strategies for autonomous driving. So why we need kind of world models? So in end-to-end system that are trained kind of large amount of human driving data set, so they provide kind of scalability, but there is some kind of issues with these end-to-end system in terms of generalization capabilities, especially their response to out of distribution scenarios. And similarly, how we can incorporate human behavior modeling to make the decisions that are coming out from these end-to-end system more rational and more explainable. So with those challenges, there are two key research questions that I'm focusing on, is that how we can improve the generalization capabilities of end-to-end system, and how we can incorporate common sense reasoning to autonomous vehicles. So ultimately, by researching on those two questions, the ultimate goal is to improve the safety of autonomous system. So a little bit background about me. So in my PhD, I was leading the autonomous vehicle project, which is funded by South Korean which is funded by Gwangju Institute of Science and Technology and the then Gwangju government. And so in that, we just use an electric vehicle and retrofit it with different sensors like LiDAR, camera, GNSS, radar, and then we use Autoware. And at that time, Autoware was not so much mature, so we design it to our needs, and we develop our own nodes to tackle perception, localization, planning, and control. And so these are some demonstration which I gave to different academia personnel and also government officials. So on the left hand side, this is a complete demonstration inside our campus. And in the second video is just showing the demonstration of obstacle avoidance. Okay. So in this modular approach, there are two kind of issues. One is scalability, and the other one is hyperparameter tuning for control. Whenever, like we were facing, whenever we change kind of environment, we have to tune the hyperparameter for the control. So to avoid this and to address those challenges, I designed a neural network based controller which focus on how to build and scale pipeline for path tracking algorithm to the actuators. And for this, I just changed the conventional pipeline, which is illustrated in figure B to figure A to B, using the neural network, where idea is to predict throttle, brake, and torque based on using linear and angular velocities coming from the path tracking algorithm. So for this, I collected the data set, human driving data set, including CAN bus data that includes throttle, brake, torque, linear and angular velocity. And then I designed a simple but yet effective LSTM-based architecture just to avoid the computational complexity to predict the throttle, brake, and torque using velocity and steering angle data. So these are some demonstration in which I use this neural network based controller with MPC based path tracking algorithm. And I also use this neural network controller with pure pursuit based path tracking algorithm. So these both are implemented on that autonomous vehicle, which I developed in my PhD. So like from the video, it is not visible, but in our experimentation, this MPC-based path tracking algorithm, when used with neural network-based controller, has better stability and better response to the system in comparison to pure pursuit-based path tracking algorithm when used with neural network-based controller. So this is kind of graphical illustration of what we achieved, is that this red curve shows the pure pursuit when used with neural network controller, and then the green curve shows the MPC-based path tracking algorithm when used with neural network-based controller. And it is shown that this green curve is more close to the actual ground truth waypoints and has better performance in comparison to the pure pursuit-based method. So moving on, so here now I'm working on how we can design a world model for end-to-end autonomous driving. So coming from modular to end-to-end autonomous driving provide a more kind of how we can design better neural network models to scale the autonomous driving. So this is a high-level overview of components that need to be built for this world model. So the first one is how we can encode the multimodal features, for example, perception, text, and action to a unified embedding, and then how we can design the world model. So like world model taking an intuition from human mind, like whenever we are driving, we have some internal map of the environment. So how we can mimic those kind of representation by designing a unified world model. And then the third one is by combining those multimodal features and world model prediction to a unified decision-making system. So we can design imitation learning-based agent to incorporate those multimodal features and world model prediction to make a more safe and reliable trajectories for autonomous vehicle. So like based on this kind of high level overview, so these are some kind of research outputs that being published in like some top tier journals. So in this one, the idea is to how we can learn the dynamics of environment and how we can develop methods that learn the contextual representation of the environment. So to uh, address those objectives, I designed encoder-decoder architecture in which I integrate the spatial perception through RGB cameras with a top-down bird eye view for contextual mapping. So together, combining these RGB and BEV representation, I pass it through some feature extraction modules, like using some ResNet architecture, uh, and then the feature which I get combined with the velocity data, so that we have some combination with the velocity, and then pass it to the attention framework to learn the interdependencies between the features. And after this attention mechanism, the features or embeddings are passed to a simple groove-based decoder for waypoint prediction module. So then in this method, I follow like two kind of evaluation setting. One is open loop setting, in which I use the new scene data set and calculate the performance in terms of L2 error, and our method shows kind of good performances in comparison to state-of-the-art methods. Similarly, we also do some closed loop setting evaluation, in which we use Carla, and there are two benchmarks that are widely being used in the research. One is longest 6 benchmark, and the other one is town 5 benchmark. So in both the benchmarks, our method achieved better performances in terms of driving score, route completion, and infraction penalty. Similarly, this one is recent work. So the idea is that in end-to-end autonomous driving, there are two main kind of approaches. One is trajectory prediction based method, and the other one is control prediction. And both have merits and demerits. And so trajectory prediction is more reliable in long-term horizon prediction, whereas the control prediction methods are better for immediate response. So the idea is, can we develop a method where we combine both trajectory and control prediction based on observed situations, so that we can achieve the best of both worlds. So for this, I designed a magnet, which is multitask adaptive gating network for trajectory digital control prediction, where we combine trajectory and control prediction through a gating network that receive the information from the input, and it decide based on situational awareness um, um, whether to switch between trajectory or whether to switch between control. So these are some demo qualitative results on the Carla benchmark, same longest 6 benchmark and the town 5 benchmark. And here you can see whenever we have immediate response, so the agent type is switched to control branch, whereas if we have a longer horizon time prediction, then it follows the trajectory agent. So contribution to Autoware. So here at Alto, we have autonomous vehicle, which we call Alex, and it is equipped with the kind of sensors, cameras, LiDAR, radar, GPS, IMU, and mostly like kind of objective to develop this autonomous vehicle is how we can develop methods that we can use in adverse weather condition. Like in Finland, we have a lot of snow, so how we can develop methods so that we can develop methods for this autonomous vehicle to drive autonomously in adverse weather condition. And the second one is here at Alto, I am planning to start a course which is on F110 course, like Professor Rahul is teaching in his institute. So so the idea is how we can uh, kind of practical based teaching, how we can develop on a small scale autonomous vehicles, so that student can get the understanding of what is the actual kind of techniques and approaches we use for this autonomous vehicle. And the other benefit for designing this course is that we are now continuously participating in the Boss Challenge. And recently, this year, we were quite lucky enough to be placed in the first 4 positions. So this is another objective for designing this course, so that we can participate in Boss Challenge. So, and also I was in Ivy like this year and the previous year, so we at Ivy, they are organizing F110 challenge. So maybe in the next year, we will also participate in F110 challenge. So what I will contribute to Autoware is I'm more towards how we can develop end-to-end autonomous driving methods using co-simulation environment, like how we can do simulation between Autoware and Carla and Sumo, so that we can develop methods for smart mobility and also smart transportation. And the other one is validating this world model representation with Autoware, which is already in progress. So, and the third one is I can like prepare lecture and tutorial for Autoware and contribute to Autoware lecture series. How the Autoware Foundation can support my goals. So currently I'm planning to write a, project for Research Council of Finland on generative world models for diverse scenarios in autonomous driving, which is kind of 4-year funded project. So what I need is kind of collaboration with Autoware Center of Excellence, and this will involve research visits. So in this project, I will hire one PhD student, and either me or PhD student will visit like any of the collaborators for 2 or 3 months, but it will be kind of decided with the collaborator, and there will be no kind of financial obligation on the collaborator and partner. And so from this collaboration, we believe that it will be kind of joint efforts toward high quality publication, knowledge sharing, and putting joint efforts to extend the current project to some EU project. And then like if we really agree on the collaboration, so from my side, I will provide the collaboration letters draft, and if somebody wants to do further discussion, then I can arrange a meeting with him or her. So so yeah, this is, and one more announcement is that we are organizing the second Safe Drive workshop in Ivy 2025, and so we have a successful first workshop in Ivy 24, and we attracted a lot of audience. So now we are planning the second edition of this workshop. So I'm really kind of interested if somebody wants to be keynote speaker in our workshop. So just let me know. So yeah. So thank you. So any question, comments?
Yeah, thanks a lot, Shoaib. Very interesting research, and I think you also clearly explained, how you use Autoware moving forward, and very exciting to see also the projects that you're working on. It's aligned with, I think, the paths, a lot of the COE members are also going towards. But I'd like to open it up to everyone to ask questions, and Shoaib also made very good offers to anyone who wants to collaborate. Please discuss. Yeah, yeah, and I believe Alex, right, from GFU, because he has also, with him we had also organized several Autoware workshops at Ivy, and yeah. All right. So anybody has questions for Shoaib?
Oh, hi, Rahul. I have a question.
Go ahead.
Simon from Tier 4 here. Thank you very much, Shab, for such a nice presentation. And at Tier 4, we're very interested in end-to-end models for Autoware. And I'd like to ask about when you want to combine with Autoware, I think that some of the world model performance, it's improving, but there's still some kind of lower performance than traditional rule-based systems at the moment, or there can be in some situations. So do you think you will combine it with rule-based, like the traditional rule-based Autoware system, and have some framework to select which behavior to use? Can you comment on that?
Yeah, so very good question. And this is kind of recent discussion in our group, like how we can combine end-to-end and whether it is safe enough to be deployed or not. So just a quick comment on this one is that like there will be kind of safety aspect. So I was thinking there is recent development in using signal temporal logic. So that can be combined with these end-to-end systems. So just to check what, like if it guarantees safety, then it can be used in deployment. And another approach for incorporating these end-to-end models or world models for this is that we can design a kind of two branch network. One is rule-based and the other one is this end-to-end. And then at the end, we can see like finding an error or some kind of this thing so that we have the both, we get the kind of prediction from the both models, and then we can decide which model to select. So obviously, this hybrid model are more suitable for this autonomy 2.0 because you never know when these world models or even these end-to-end autonomous driving fail, or because if we don't have any kind of uh, out of distribution scenario. Rather, we are discussing like we are solving these out of distribution scenarios, but there might be some cases that can be encountered while these autonomous driving. So the best approach is to use hybrid model combining both rule based and also these end-to-end models for better autonomy. Yep.
Okay, great, thanks. And Mitsudome-san, you just mentioned in the chat about a working group to discuss this. Do you want to just say something?
Yeah, sure. So yeah, this is not a question, but a comment. But so in the Autoware Foundation, in the previous TSC, the new working group establishment was approved, and planning to kind of start a working group called AP 2.0 working group, to kind of discuss how we can kind of integrate these end-to-end models with Autoware. So yeah, we're planning to start the meeting from November, so from the next month coming up. So yeah, if you're interested, please join and yeah, share some ideas. It might be also nice if you can also share the presentation that you shared today to those working groups as well, so that they know what you're doing and yeah, how we can help you out with them.
Yeah. So can you just send me an invite? So then I will definitely join it.
Great. Yeah. When we create it, I will make sure you'll be invited.
Yep. Okay. Thanks a lot.
Hi, hello. This is Alex, like your car, from Gifu University and Nagoya University. It was very curious and very interesting and very curious to hear your presentation with your initial part that your research is currently in Aalto University, that you're originally from Pakistan, and that you were working on world models for autonomous driving. As I put in chat, I was co-supervising a PhD student whose work was from predictive world models. His effort was to predict, in particular, try to work with mapless navigation. So to make predictions or make hypotheses of what will be the road ahead, and match the observations with the several hypotheses that he is generating. So in that way, he is able to achieve a method for navigating without prior maps, and basically using observations and AGI techniques for predictive world models. So that's one of the curiosities, that he was originally graduated from Aalto, and I just received a new PhD student from Pakistan. So there is an interesting connection in all the things that you mentioned. So looking forward for any chance to cooperate with you guys.
Yep. Thanks a lot. So yeah.
So Raul, maybe one more, just quick one. And Raul, do you recall, since Shoaib mentioned the STP, Raul, was it a guy from Waterloo University? You had someone present a while back that was very centered on STP. Do you happen to recall?
Yeah, the signal temporal logic. Yes. So
Yeah.
so I guess
Was he Waterloo?
No, he's Yash Pant. He's my former student, and actually his thesis work was on using some signal temporal logic for, building safe autonomous systems. And yeah, so I think that's a good point, David. So Shoaib, there are a couple of us that work on and I would say also Jin Hyung Kim over here from GNU University in Korea, and Dogun also from Turkey, from Boğaziçi University. So there are at least four, five of us who all work, on signal temporal logic and the combination of formal methods and controls, and especially with learning-based controls. So I think you are in good company. At least on the academic side, I think there will be lots of opportunities to collaborate and what I encourage everyone is to invite, Shoaib. He obviously presented a lot of stuff in a very short amount of time. There's lots of details, very good papers there. Especially the last one, I think was very interesting. To present in your research groups, and that's a good way to have a much more in-depth conversation. Today is just a good introduction, and I think it really sparked a very good discussion. So, Shoaib, thank you so much. This was, very eye-opening. I think it's also, as Mitsudomi-san mentioned, very aligned with the path, Autoware is moving forward with the building the 2.0 stack. And this combination is exactly the kind of philosophy of, kind of this switching between a neural network-based controller and a safe kind of short-term MPC-based controller. Uh, both are very aligned, and I think these also would serve very well as having as an Autoware project, right? So
Yeah, thanks a lot.
thank you so much. So I think we can move forward to a more open discussion. I think there are a few people. Michael from Poznan University mentioned he had some updates to provide and some project directions. And we'd love to hear from anyone else also. Just for anyone who just joined, I think Daniel Shi and Abhijit, welcome. And so essentially, we have streamlined the process thanks to Mike Coraluzzi, who's our project manager for the Autoware projects, COE projects, and Pojan Wang, who's Autoware engineer. And we are onboarding all the teams. And if you send us a message, we can just sort of set you up with a very easy project intake procedure to get your COE project started. Go ahead, Michael.
Okay, hello everyone. Just to introduce myself, it's Michael from Poznań University of Technology in Poland, and together with Krzysztof Walas, Christoph, we have like let's say, a loose relationship with the Autoware and autonomous projects for a few years. There are like three areas that I could update you right now. So the first one is that we finally assembled and can teleoperate our electric go-kart. So we can finally move towards the autonomy. I don't have more information on this from Christoph yet, but we are making progress. The second one is like a few months ago, even maybe more than a half a year, I was like presenting that we successfully deployed the Autoware with one of our commercial partners. It was Samsung doing the autonomous delivery between in the factory. And I can say that it's like working reliably quite well. So it's we went from like let's say proof of concept phase to something that can reliably support. And it's still a proof of concept, of course, but it's working and it's less and less requiring our input and more working. And the third one is that we are still waiting of our new project that should kick off soon. I hope that it will be next month. That will be about using Autoware for going off-road. So we would like to focus on the perception to be able to predict how easy it is going to be to drive over this road, and also we will be focusing on having like a, let's say, possibility to teleoperate without connection to the internet. So some using some direct communication between the operator station and our vehicle that will be built to works in the more outdoor environment, maybe in the forest, maybe some roads there. We will see how it goes. So this is just a brief update from us, and of course, everything takes more time than anticipated, but we are moving forward.
Cool.
Thanks.
Thank you, Michael, and please say hi to Christoph. Yes. So
Of course.
all right. So we can have any other updates from other members. Yes. Yeah, and this could include, like, I think we have a couple of workshops that are being organized. I know last time Josh had mentioned his workshop. I think now it has officially been announced. So maybe Josh, you can also just describe your workshop and invite people to submit to it. Yes.
Sure, absolutely. Let me share my screen. Okay, so we are running a workshop on software engineering for autonomous driving at ICSE, the International Conference on Software Engineering. So it's the #1 conference in software engineering research. And as you can see here, it's being held in Ontario, Canada. So those of you nearby there should be pretty convenient. And really, you could think of you can think about this workshop as essentially focusing on providing tools, infrastructure, and data sets to support what a lot of you are doing here in terms of actually building the autonomous driving system and its components, whether that's end-to-end, deep neural network-based, rule-based, and so on. We'd like to ensure the security, safety, robustness of those systems, and possibly expand beyond uh, just the maybe maintenance end. So, for example, if anyone is more interested in requirements engineering or software architecture aspects of autonomous driving, I know that there was an Autoware competition, I think maybe being managed by Tier 4 that even looked at software architecture aspects. So the submission deadline is November 11th for here, for this workshop. But besides this workshop, I think I've invited some of you. We're actually going to hold a local UCI workshop. The plan is either later this year, December, although that's coming up fast, maybe too fast. So more likely, we would probably hold that January or February. So for those of you, especially maybe like, for example, in the East Coast of the US, where the weather might not be so great at that time, it's a great opportunity to come to Southern California and enjoy the sights there, whether that be like the nearby Disneyland here or all the other theme parks like Universal Studios or Legoland and so forth. Beyond that, for the first about 10 to 13 participants, we're offering up to $750 reimbursement for travel expenses. So if you're interested in that, we're inviting people not just among the Autoware COEs, not just among software engineering, but also security people as well, for example, like Alfred and myself. And so please reach out. I'll also send out individual invitations as well. And yes, thank you. Thank you for your time. And I'm happy to take questions now as well if anyone's interested.
Cool. Thanks a lot, Josh. I think this is very exciting, both the workshop and this planning exercise. Yeah, I think so. So I think for the folks, that have already submitted the proposals, we are sending out this right after today, the AWS credit form. So all you have to do is just enter your AWS account number, and then we will follow up with AWS to provide credits, and you can use that for your project or for any projects. All right. So any other folks want to provide any updates over here on any events or projects you would like to discuss? Yes.
Yes, hello. This is Alex. If I may, just wanted to invite the COE members to help co-organizing the 7th Autoware workshop and third Autoware tutorial at IBE 2025. The deadlines are coming close. I'll just attach them into the chat. So workshop's deadline is November 15th. So yeah, a couple of weeks. And the tutorial deadline is December 3rd. For the workshop, there is a new convention in IBE that we have to check whether the workshop is aligned with any of the ITSS activities. And if so, then we have to seek the cooperation of the persons running the activities. I believe that Autoware and say open source software for autonomous driving related activities have not been happening yet at ITSS, which is not a bad opportunity. It's a good opportunity to link with them. But that, at least for the moment, it will simplify the submission to the proposal for the workshop. So please let me know if any of you are interested to collaborate with the organization of the workshop. Thank you.
Yeah, and
Rahul,
just to follow up to Alex's, we've had the Autoware IV workshop mostly represents actually like the coming together of the COE members also, and so the workshop is a very good opportunity. As you can see, I've posted a link for the IV workshop that we recently hosted, and chaired by Alex. And it allowed a lot of the folks to come together and present, research based on, Autoware-based systems, but doing many different aspects of it. And so it was a really packed workshop with a lot of discussions, a lot of presentations. And along with that was the Autoware tutorial. And that was with many members were basically presenting their software that they have added and extended with Autoware. It's a great opportunity, and I highly encourage everyone to look at the IV program in Romania, and please reach out to Alex, to me, to Pojan, if you want to be part of the IV, either as a co-organizer or a speaker or submitting a paper also, and a tutorial. We will definitely follow up with everyone once, as we are preparing for that. Yes, thank you, Alex.
Sure. Actually, I already have a potential presentation for the tutorial. We have been working with this new driving simulator called BeamNG, and we managed to make the integration with Autoware. The great thing of that is that includes several maps, including maps in Japan. So driving on the left, driving on the right is no problem. Indianapolis racing courses are included, etc. So it's a great environment. So we'll bring a lot for that story.
Great. That's wonderful. Yes. All right. And William, from your side, and Abhijit from your side, if y'all have any updates, please go ahead.
So I would like to just update about one IV workshop that we are possibly going to propose this time as well. So last time we did a workshop on smart infrastructure and UAV, and Rahul, you gave a presentation there. We were just discussing the other day. My German colleagues were very excited to see that you basically ignited some of the discussions on that day. So which was very good. They were asking if you are available again. So you are welcome to join again. But I want to just extend my invitation to everyone. So it will be on smart infrastructure, UAV, but we are probably expanding the scope a little bit in terms of putting that into a smart city infrastructure. Is how it fits into. So if anyone is interested in presenting, please let us know while we are developing the proposals. We can just include you as the potential keynote speaker, and the more details we develop, we will send it to the whole group. Thank you.
Abhijit, when was that event?
This will be during the IEEE IV 2025.
Got it. Yep.
It will be in June, I guess, next year.
Where is that, by the way, guys?
It's in Romania. Am I right? I think it's in Romania this year.
Correct. It's in Romania.
Yes, that's right. So that and the IV is a really good coming together of folks. And actually this year I had a good discussion at ITSV, the Intelligent Transportation Systems Conference that was recently held in Edmonton. And ITS Society will also sponsor the F110 competition at IV in Romania. And there are obviously challenges. They want to host it in some fancy place in downtown of this beautiful city. But we're working with them, and our goal is to basically have as many vehicles running Autoware in the competition. That way we actually can take it to the next level. So there will be many different events happening in IV. We already have the Autoware workshop, Abhijit's workshop on the smart cities. Abhijit, if you have a link to the Jeju workshop at Jeju, you could share that in the chat also. Yes.
Yes, I'll do that. Thank you.
Yeah. William, you can also provide an update from University of Delaware.
Okay, sure. So from the University of Delaware side, we will have a tutorial/workshop at the IEEE MOST conference that'll be happening in May 2025. And in the tutorial/workshop, we will mainly talk about our Autoware and V2X attempts. And we will have a demo, we will have some tutorials, and we'll slowly be opening up our testbed to the Autoware Foundation members.
Great. Thanks, William. So I also posted a link to IEEE MOST, and then over here too, we will have opportunity for all the Autoware COE members to actually provide presentations and updates. And this is held in Delaware, not too far from Philadelphia, actually, just less than 35-40 minutes away. So then if you go there, then please come and visit us in Philadelphia, and we'll have a lot of joint activities with Professor V. Songshi and William's team over there.
Rahul, can I?
Yeah, Venkat, please. I was going to call on you next. Thank you.
Hi, folks. As you may be aware, there is the F110th competition that Rahul, Johannes, myself, and a few others have hosted quite regularly. They're starting with IROS. So the portions I've been associated with are mostly the robotics conferences, ICRA, IROS. And at this past IROS a month ago, we started the first simulation league. which had over 50 participants. And we're following that up with a second simulation league, sim racing, as well as a 20th or 21st, I lose track, of a physical racing league. I put a link to the sim racing league into the chat, where we've had a number of people, including Autoware enabled teams, participate in the virtual racing competition. Our sort of longer term goal in this is to be able to look at how to reduce the sim to real gap. So train completely within a simulation environment and do zero shot transfer to physical environment. Please check it out, and we remain available to help you debug any aspects of the simulator.
So Venkat, you put the link in the chat?
Yeah, earlier.
Oh, okay. I think it went up. Okay, I will just
I'll put it again.
Yeah, you can.
Yeah,
Great. And we will share all these links after the call in the meeting minutes, so you will have access to all of them. Yes, David, please go ahead.
Yeah, just a question also in the off-road context or the outdoor context. Venkat, and I know, William, you guys had some space down there in Delaware too, where we're considering some off-road type tracks. But this is particularly interesting if, as you build out the sim, there is at least one area somewhere where one can kind of, have the real world version thereof, and I'm thinking in the off-road context, but to have, either like at your facility or even, a couple different places, it's not as much, infrastructure required as say a high-speed on-road race, but to be able to start to compare that sim to real, so there's at least one location, where you can have people prepare from around the world for that with the dynamics in the sim, and then see how it works out with slip and jumping and all that stuff. So any considerations on the off-road or some sort of like place where the off-road might find itself in the real world in the future, some events, some tracks, or anything like that?
Yes. Thank you, David, for bringing accepted at the Transportation Research Board annual meeting that will be happening in January 2025 at Washington, D.C. And for the poster presentation, that is related to our simulation and extendable CoSim platform, where we talk about how we built the University of Delaware digital twin, including the on-road and the off-road, all of that, etc. So if you guys are in the area, you should definitely come to TRBAM in January to check out the posters. And yes, and to answer your question, David, yes, we will think about building a off-road environment. Yes.
And at least from the F110 competitions perspective, I think Rahul can give us a better update, but I think there are plans underfoot to start to transition from a purely 2D racetrack to include varying levels of terrain roughness, terrain traction, which will start to challenge some of the planarity assumptions, right? And so, if you're interested in this, we're happy to discuss more on how to make it very challenging.
Yes, I think as we, in parallel to this Autoware 2.0, really one other way to push the limits of a much more learning based perception planning control stack is we're looking at like off-road driving, off-road racing, but with 1/5 scale vehicles. And this is another way, because now the terrain is unknown, or the terrain is rapidly changing, and it's difficult to estimate friction, and you're on a 3D track. So it forces you to have, a much more learning based stack. And so that's one of the motivations of going in that direction. And if folks are interested in that, please, reach out. And I think we have quite a good critical mass of people interested in doing that together, and we could do activities together in that direction.
Yeah, and they could, Raul, also join, Pojan's racing working group too. We've been discussing that a little
Yes.
bit in that forum as well. So if anybody's interested, please feel free. Yeah.
Yes, yes. All right, so I think this is a good place to stop unless anyone else has any last thoughts. But just to wrap up, I once again encourage folks who we have reached out to, and also everyone else here on the call, to submit your COE projects. And it's a very simple and easy process, and we'll just help you get on board. And we can then have a much more formal and meaningful engagement of research and helping your team from Autoware and making sure all your work actually can be given the full publicity and scale to a larger, broader Autoware community by integrating it into the Autoware universe. And as usual, feel free to reach out to me, to Pojan, Mitsudami-san, CJ, Mike, for any questions you have. We are here to help everyone, get their Autoware-based projects running, and also to engage on the research aspects. Cool. Thank you so much. And once again, Shoaib, thank you again. And I'm sure we will have lots more follow-ups after this. And welcome to the COE. Yes.
Thanks a lot. Thanks a lot.
Okay, thank you. Bye-bye.
Thank you. Bye-bye.
Have a great week ahead.
Bye.
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 Thank you. Bye.
Bye.